In this video, we're going to talk about sound modification using the filter. So I'm going to pick up right where I left off. All the settings from the last video are still in place. So the filter has two modes. There's a high pass and a low pass mode. Just really quickly, what that means is that if it's in low pass mode, as we decrease the cutoff amount, anything above that is going to be filtered out of the sound. So let me turn this up. So now only the lowest frequencies are passing. And vice versa, in high pass mode, it's the opposite. So when it's turned all the way down, all the frequencies are going through. And as we turn it up, only the highest frequencies are passing through. Let's set it to low pass for right now. So the cutoff is at which point the filter kicks in and starts filtering out harmonics. It's a 4-pole ladder filter with 24 decibels of attenuation. So resonance, it creates a peak at the cutoff frequency. And also something that's specific to Moog that's not in some other filters is that as this goes up, the bass can be sometimes lowered in the cutoff. So let's hear a little bit of that. I'm going to turn this up again so you can hear the sweep. So the cutoff's right in the middle. And as we turn this up, it's really accenting that frequency. But you can hear some of the bass has gone away. And here's a diagram to illustrate that. Just like we went over in the last video, how the envelope impacted the pitch, the envelope here is going to impact the cutoff frequency. So right now, it's not having any impact because this is set to 12 o'clock, which is essentially off. So because our envelope is off, the decay won't have any impact on the sound. Listen. It's not doing anything because the envelope isn't taking any effect. And just like the envelope on the VCO, if you turn it to the right, clockwise, then it turns in a positive value. But if you turn it to the left, it turns negative. So what's going to happen is as we turn this up, the cutoff frequency amount will start high and switch back to its original value. And if we turn this up, the decay up, just like on the VCOs, it'll happen slower. Turn it up all the way for a dramatic effect. And we end up right back at our original value. If we turn this down, it'll happen very quickly. So that's the same thing if I were to turn this off and just manually do it. I'll use both hands. That does the same thing as if turning this up. See if I can get it exactly. And how high you turn this up means that this will have a greater impact. The starting point will be even higher. Whereas if I were to turn it here, it would have a lower effect, like maybe like this. And the reverse is also true. So if we turn this to a negative value, it's going to have this kind of swoosh or sweeping as the cutoff goes from a very low amount up to the higher amount. And if we turn this to high pass, it's going to start basically as if the cutoff was set, or as if the filter was completely off, and turn it into, go to about halfway. So this is a great way to get some like swooshing, kind of weird sounds. But there's another way to modulate the cutoff frequency, and that's using the noise VCF mod. It uses the onboard noise generator to actually sort of shake this cutoff frequency. And creates like a distorted lo-fi sound. I like to describe it as fuzzy. So let's hear what that sounds like. I'm going to turn this up so it lasts longer. To me, it sounds like a fuzz pedal. And of course, you can get crazy. But this can sound really good, especially with the VCA decay being a little bit tighter. You can also modulate the cutoff frequency using the patchbay, which we'll discuss in the patchbay section. So I hope that gives you a good idea of how the filter works. In the next video, I'm going to talk about the VCA section.